What's up? We're talking about multiplying polynomials, and one way to do that is with what's called an area model. And when we go through this today, just think area models. So we've done simple things like this before. 9 times 4 gives me the area inside. Now we're going to use that same process, except now we have parts that aren't known. We have our variables in it. Same process though. So let's see what this looks like. All right, so when I have x plus 5 times x plus 3, these two quantities are like the sides of my rectangle, okay? So I'm going to set up, I have x plus 5, I'm going to give myself some room here, and then my other side is going to be x plus 3. Then I'm going to draw my box. My job is to find the area of this box. That's what multiplication is, right? When you're multiplying two quantities anyway. All right, so here's what we do. Just like when I had my square and I said 9 times 4 was 36. So same idea, I just have more pieces involved, right? So I'm go x times x, that's going to be x squared. Watch your exponents, right? Same variables multiply, the exponents add together. X times 5 is going to be positive 5x. So I'm done with that row. Now I do 3 times each part as well. So 3 times x is positive 3x. And 3 times 5 is positive 15. Okay, I like writing the signs because it just will help my brain keep track of, like, do I have positives or negatives, right? Helping me see what operations I'm doing. What I like about this method is I can see my like terms will always be on the diagonal. And what we're going to do is we're going to go from the top left and we're going to make our way all the way to the bottom right. Okay, so I have x squared, there's no other x squared, so x squared. I have 5x plus 3x, so I have plus 8x, and then I have that plus 15. That's as far as I can go because there's no other like terms. That's the product when I multiply x plus 5 times x plus 3. That would be the area of that square, that rectangle, okay? That's what the area model is. All right, let's try it again. 2x minus 2 times x plus 11. So remember, those are the two side lengths for my rectangle. So 2x minus 2, and then I have x plus 11, set up my box, all the pieces, and then I multiply, okay? X times 2x is 2x squared, because 2 times 1 is 2, x times x is x squared. X times negative 2 is going to be negative 2x. Then I go to the 11. 11 times 2x is 22. X, 2 times 11 is 22, then times the x. 11 times negative 2 is negative 22. And now I want to know what is this area, so I'm going to combine like terms, start in the left, end at the right. So here we go, 2x squared. There's no other x squareds. 22x minus 2x is going to be positive 20x, and then minus 22. All right, so over and over, that's what we're doing. Let's try it again. I have 3x minus 1 quantity squared. So just remember, when we square something, we're multiplying times itself. So there are my two side lengths. Okay, so 3x minus 1 times 3x minus 1. Set up my rectangle. And we multiply to see what goes inside. 3x times 3x. 3 times 3 is 9. X times x is x squared. 3x times negative 1 is negative 3x. And now I do negative 1. Negative 1 times 3x is negative 3x. Negative 1 times negative 1 is positive 1. So it's really important that you stay engaged, like mentally what you're doing. Remember, area is multiplication because it's really easy to slip into addition, subtraction, right? Because we see those positive and negative signs. So make sure first we multiply inside, then we combine, right? So I have 9x squared, no other x squared, so 9x squared. Negative 3x and negative 3x is negative 6x. And then I have that positive 1. That's the product. All right. Same thing still applies even when I get this really long polynomial right there. Same exact thing. I still have two sides of a rectangle being multiplied together. Okay. So x squared plus 3x plus 1 You could write that on the side. I like having the longer ones on top, but really we would get the same result. 2x minus 4. Set up our rectangle with all of its sections to tell me what I'm multiplying, right? And then we multiply, okay? 2x times x squared, remember there's a 1 there, so 2 times 1 is 2. X times x squared becomes x cubed, right? Add the exponents. 2x times 3x, 2 times 3 is 6. X times x is x squared, and that's positive 6x squared. 2x times 1 is going to be positive 2x. I'm done with that. And I go to negative 4. Negative 4 times x squared is negative 4x squared. Negative 4 times 3x is negative 12x. Negative 4 times 1 is negative 4. Whew. Yeah, lots of pieces. Just be methodical and organized. All right, combine like terms. Look, my x squareds are diagonal, my x's are diagonal. Kind of cool. We could still go left until we get to the bottom right. So I have 2x cubed, that's the only x cubed here. 6x squared minus 4x squared is going to be positive 2x squared. Negative 12x plus 2x is going to be negative 10x. Then I have the minus 4, and there is my product. There's no more like terms. Remember, like terms, same variable, same exponent. That's as far as I can go. So that's the area model for multiplying polynomials.